In order to really understand how the deallocation process works, we need to understand the underlying algorithm that that manager uses. So as you can see, it's a pretty basic script, a byte of code that goes through all the scenarios that this deallocation process might see. And that's pretty much everything that it's going to see. So to break it down a little bit, we are going to go if the job location or the memory space address that that process takes up is adjacent to one or more free blocks, it will then look at this. If that memory space that's being taken up by the process is between two free blocks, so you'll have the process here, and then a free block here, and a free block there, it's going to combine all those into one. Yep. Then merge all three blocks into one block. All right. Now, if the job location is not between two free blocks, and it has a block above or below it, then it's going to merge both blocks into one. So you have a job here and a free space here. It's going to combine them into one. We'll go through this in more detail when we go through each and every case that this will see in a little bit more detail. Now, if the job location doesn't meet this or this, it will search for null entries in the free memory list. All right. Now, if you have a null entry, we'll explain what a null entry is, but in basics, it's just a process that has already completed, or when three blocks have merged into one block, you're going to get a null entry in there. But we'll explain that a little bit later. Now, once this algorithm has found a null entry, it's going to set its status to free, and then give it the beginning address in the entry slot of the previous process. But like I said, we're going to dive into each one of these cases one by one and explain more of what's going on. All right, in case one, for our memory, we are joining two free blocks. This column, the green are the free blocks, the blue is a job occupied in that memory space. That occupies 7600, the address of that memory space. And the free blocks surrounding it, 7500, 7800. Now, in this case, when we're joining two free blocks, we are going to join 7500 and 7600. So, once it's done, and the algorithm for deallocation has run its course, it turns into this picture over here. See how 7600 is free, 7500 is free? It pretty much just combined those two blocks and started at 7600, where the job previously occupied that address space. And you see 7800 here, that address space is no longer there because 7600 and 7800 combined. So that was combining two free blocks. All right, in the second scenario, a deallocation algorithm might have to join three free blocks. In this case, we have blocks 75, 76, and 78. Now I say blocks, but 75 is the starting point in that specific memory address. 76 has the process running at that specific memory address, and so on with 78. Now these are in the hundreds, so 7500, 7600, 7800. All right. Now when we want to join three blocks, we want to take the process that's running at 7600, 7800, and combine them with this process that's not, well, this empty memory space here at 75. All right. Now, the end result is this right here. As you can see, since 7500 had the empty block, it's going to have the empty block over here. Now 7600, since that had the process, and 7800 had no process, they get moved up and combined with 7500 at the start of that memory block. Now, since 3 blocks are combined into one block is going to be null, as in nothing's going to go there, nothing's going to take up that space until the algorithm sets that as null, and then, as we'll explain in case number 3, what happens to a null block. All right? All right, in case number 2, we talked about joining 3 free blocks into one available memory space. In the process of joining those 3 blocks, I showed you at the end of that case a null entry or isolated block is created. So we're going to dive into that a little bit more. In case number 3, deallocating and dealing with isolated blocks, aka null blocks. All right. So here we have a process that's running right now on memory space 8800. All right. Once that job gets done, it frees it up and creates a null entry. Hence, we have the blue here. Let's just say the blue block is a block that has a null entry. Oops. Put that back up. So, in order to deal with that, the algorithm goes through. It goes through each scenario one by one. In the case of, it'll go through when we talked about case 1. It'll go through that scenario. If that is the case, run this function. If this is not, then run this. Else, you'll have a null block, and it'll run this function. So, in that case, once it gets to the bottom and it finds a null block, it converts it and sets it to a free memory block, free memory space, starting here at 8800, because that's where the null job or the process before occupied. So this process occupied address space 8800. It finished, created a null entry block. The algorithm saw that, went through the process, and converted it to a free memory block at the same address space as the previous process.